So let's continue with our discussion on quadratic equations chapter with on the subtopic of the nature of roots, right? By nature of roots, I mean the nature of the value of x. You'll see what exactly I mean by it. So to recap, we know that the general form of a quadratic equation is ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is a constant term, all three being real numbers, and a is not equal to 0. We've also studied the quadratic formula to find the value of x as being minus b plus or minus square root of b square minus 4ac upon 2a. We've done this in the previous videos. Now this value that you see under the square root sign, b square minus 4ac, yeah, that's special. That is called as the discriminant, right, and denoted with the alphabet d. Okay, and it is this value, the value of the discriminant, that determines the nature of the roots that we have. Okay, so we have three conditions for it. The first condition being the value of d being less than 0, or I could say the value of the discriminant being negative. So I have, say, for example, the value of d being minus 13, right? And so what that means is the value of d is negative. My roots now are in the format of, say, something like minus b plus root minus 13 upon 2a, right? And the other root is minus b minus root minus 13 upon 2a. Okay, now note one thing, we have negative values under the square root sign, right? So we have minus 13 minus root 13, we have negative values under the square root sign, and such kind of numbers with negative values under the square root sign are called as imaginary numbers. So when d is less than 0, our roots are imaginary. The roots of the quadratic equation are imaginary or unreal numbers, or not. Roots are not real. Yeah? Imaginary numbers are something that we'll deal with in more detail in our higher classes. Okay. The second condition now is, so the first condition is d less than 0. The second condition is when d is equal to 0, right? And so understand the square root of 0 is 0. So in that situation, when I put 0 over here, my two roots of x, right, the two values of x is minus b plus 0 upon 2, yeah, minus b plus 0 upon 2a, and the second situation is minus b minus 0 upon 2a, right. And as you can see, adding 0 or subtracting 0 does not really change the value, so both of these will be equal. So when d is equal to 0, in conclusion, I can say that I have two roots and both of them are real and equal to each other. Yeah, so this is the conclusion that we draw. When d is equal to 0, the roots are real and equal. Right, now the third and final condition that we have regarding this is when d is greater than 0. Right, so we saw d less than 0, equal to 0, and now greater than 0. So if d is greater than 0, get it? So suppose if I have a number like 13, plus 13, right? Now I'll have one root which is minus b plus root 13 upon 2a, and the other root will be minus b minus root 13 upon 2a. These are two different values, both real numbers but different values. So in the situation where d is greater than 0, my roots are real and unequal, because once I'll be subtracting root 13 and in the other case I'll be adding root 13. So these are my three situations. Okay, so to conclude, the nature of the roots is determined by the discriminant, which is the value of b square minus 4ac. There are three conditions. The first one is when d is less than 0. For d less than 0, we have roots which are imaginary, right? Second situation is when d is equal to 0. In that condition, we have roots which are real and equal. Okay. The third condition is when d is greater than 0. In that situation, we have roots which are real and unequal, or real and distinct as well, or we could call them distinct. Yeah. The next few videos will be based on, will be like applications of this concept, will be sums based on the application of this concept.